Interhalogens. Interhalogens means so mixed of two electronegativity, large electronegativity and small size halogens are mixed with interhalogens. Okay. So in this there are preparation methods and general properties and classification. Okay, na? These are like 4 types. Okay, AB, AB3, AB5, and AB7. Okay, na? These are 4 types. Interhalogens classified as 4 types. So the oxidation state, this one is +1, AB3 is +3, AB5 is +5, AB7 is +7. Okay, this is linear structure and this one is T shape and this one AB5. Okay, na? Last class AB and AB3. AB and AB3. So AB and AB3 in yesterday class. Next, we are discussing about, okay, we are discussing about AB 5 type, Okay, polyhalides. Polyhalides are anions containing two or more halogen atoms of same or different type. Halogen atoms with okay, see, polyhalides anions containing two or more halogen atoms of same or different type of halogens atom with two or more same different type having positive charge. Okay, ఇక్కడ see చూడండి. What is polyhalide anions containing two or more halogen atoms are same or different. Cl, Cl. Okay na, లేదంటే Cl, Br. Okay, Br, F. ఓకేనా, రెండు బిఆర్ బిఆర్, రెండు సేమ్ ఉండొచ్చు, రెండు డిఫరెంట్ గా ఉండొచ్చు, డిఫరెంట్ టైప్. హాలోజన్ ఆటమ్ విత్ టూ ఆర్ మోర్ సేమ్ ఆర్ డిఫరెంట్ టైప్ హ్యావింగ్ పాజిటివ్ చార్జ్ cations are also known as polyhalonium ion. Okay, halonium, nium, IUM, the name end with IUM, that is cation. Hydronium cation, hydrazonium cation. Okay, like this. Okay, ammonium cation, NH4 plus ammonium, the name end with IUM, that is cation. Okay, they are interhalogen cations and anions. Okay, next one, see, polyhalides. Okay na, polyhalides are interhalogen anions. వీటిని ఏమంటాం, interhalogen anions. మధ్యలో సూడో హాలోజన్స్ ఏమంటాం, హాలోజిన్ అయాడ్స్. ఓకేనా, సి ద ప్రిపరేషన్ లైక్ just one preparation, see this, they are obtained by addition of halide to halogens. Halide to halogens, see, Ki, potassium iodide plus iodine, it form Ki3, Ki3. Okay, this is an anion plus I3 minus, plus I3 minus, K plus or I3 minus. Second one, they are also prepared by the direct addition of interhalogen of halides. See, KCl plus ICl. ICl is interhalogen. The form of KiCl2. The form of KiCl2, and Cl radical, Cl negative ion is react with direct ICl interhalogen. The form of Cl2. Okay, so these are the preparation methods and properties. Okay na, properties. Polyhalides are colored and intensity of color increase with atomic number of halogen atom. Okay na, polyhalides are colored compound. Polyhalides are colored compound and the intensity of color increase. Akkada in the interhalogens anevi color but decrease in the atomic number increase. Decrease in the atomic number increase. But here intensity of color increase with atomic number increase of halogen atoms. Polyhalides are polyiodides. Okay na, polyiodides are black. Polyiodides are black. Polybromides are red and chlorobromides are yellow. Okay na, chlorobromides are yellow. They are soluble in water and dissociate in solution. So see, I3 minus dissociate into I2 plus I minus. Okay, and heating, CSI3 is dissociate into CSI plus I2. Okay na, these are the some properties. And see the structure of polyhalides. ICl2. See, iodine is, you know that 5s2, 5p5, 5d0. Okay na, see, undergo first excited state, one electron from p orbital into d orbital, see, one s orbital, 3 p orbital, 1 d orbital. Okay, see, sp3 dehybridization with 3 lone pairs. Okay na, with 3 lone pairs, it has linear shape. Okay na, like this. How to calculate the, how to assign hybridization is, iodine is 7th group. You put 7 valence electrons, 1 2 3 4 5 6 7, and ICl. Okay na, ICl minus, okay na, ICl minus 1. So these are 1 2 3 4 5. Okay, now 1, 2, 3, 4, 5, 3 lone pairs and 2 chloride ions. 3 lone pairs, 2 chloride ions. So involving 5 sp3d2, 5 sp3d hybridization, and there are in equatorial position there are 3 lone pair of electron occupied, and axial position 2 chlorine ligands are occupied. So this is actually it is trigonal bipyramidal, but in equatorial position there are 3 electron, okay, lone pair of electrons. So in axial position there are 2 chloride ligands. That's why the shape of the molecule is sp3d hybridization with 3 lone pairs. It is linear geometry. It is linear geometry. Okay. Next, ICl4, ICl4C, ICl4, 5s2, 5p5, 5d0. So iodine 53. Okay, na? Second excited state. This also electron from 5p orbital, 2 electrons jumped into 5d orbital. This is sp3d2, sp3d2, square planar geometry because it contains 2 lone pair electrons. It contains 2 lone pair of electrons. 2 lone pair of electrons. Okay, so this is polyhalides. These are the polyhalides. Finally, okay, this is no need to. Okay, so this is important in this. Okay, basic nature of iodine. Simple one. We'll complete in 5 minutes. See, basic nature of iodine. Okay, now from this lesson we have to read. Okay, so 5 to 6. Okay, now I already tell class just properties of iodine, properties of halogens. Okay, properties of atomic number and what is atomic weight and electronic configuration and melting and boiling point and ionic radius, electronegativity and oxidation state. Okay, now these are the important. Then interhalogens. Okay, now interhalogen preparation, properties and structure. Then pseudohalogens, then polyhalides, then basic nature of iodine. So the basic properties of halogens decrease down the group. Okay, na? Decrease down the group. Fluorine, chlorine, bromine, iodine. Okay, na? Decrease down the group due to decrease in ionization potential value, En value. Okay, na? It is highest electronegativity, low electronegativity. Okay, value, and hence that does not form F plus ion. Does not form F plus ion. Iodine being more electropositive in the group of form of I plus ion. Because fluorine is a highly electronegative. It only shows F minus. But iodine is highest electropositive. It shows basic properties. Iodine exists as I plus, I3 plus. Okay. See, evidences for unipositive cation. See the first one. Electrolysis of ICl liberates I2 at cathode and Cl2 at anode, which shows positive or basic character of iodine. See, 2 ICl, I plus ICl minus 2 at anode, I2 plus 2 Cl2 at cathode, I2. Okay, na? So this is showing up iodine shows positive. Okay, na? Iodine shows positive nature. And electrolysis of ICN also liberate iodine at this is also. Okay, ICN, I plus Cn minus. See, what is the point is basic nature of iodine is the basic properties of halogen decrease from top to bottom. In group, top to bottom decrease due to the decrease in ionization potential and electronegativity value. So hence does not form F plus ion. Iodine being more electropositive in the group form I plus ion. This shows basic nature of iodine. And this is also I plus 3 also. Evidences for tripositive ion. Evidences for unipositive ion. Okay. So this is the halogens. Okay, na? The lesson is halogens, 7th A group elements, 7th A group elements. Okay. So in unit number 2, next we are discussing about number 3. Okay. See, group 0 elements and their compounds. Okay, na? Group 0 elements and their compounds. 0 group elements are 8th A group elements are inert gas, are noble gas. So these are all are same. 0 group elements, 8th A group elements, and noble gas and inert gases. These all are equal. These all are equal. So in this we are discussing. Objectives. You know that. So what is the objectives and introduction and the occurrence? So how the 0 group elements are occurs in earth crust. Okay, and the discovery. Okay, na? Who invented the these elements? Okay, na? These are all are inert gases. Okay, and isolation. How the noble gases isolated from the atmosphere. Okay, na? From the atmosphere. And what are the properties of elements? Okay, na? What are the properties of elements and the uses of noble gas elements? How they use in industrial and chemical applications. Okay, na? In applications of in industrial method. Okay, and then structure of xenon fluorides. Okay, na? Structure of xenon fluoride, XeF2, XeF4, and XeF6. Xenon fluorides and shape of xenon fluorides. Structure and preparation and shape as no structure and preparation and shape of the xenon fluoride. Final summary. Okay, na? So main concept. This is so what is the objectives? Okay, na? In this lesson, so what we are discussing in this lesson is see. Okay, now after reading and understanding material presented in this unit, you would be able to, what you are understanding in this unit is explain why 0 group elements are placed at the end of each period in the long form of periodic table. You know that 0 group elements are, so this is S black, okay, this is D black, and this one is F, S, D. Okay, na? 1, 2, 3, 4, 5, 6. Okay, na? Here 0 group elements are placed. This is P black. S, D, P, F. S, P, D, F. 0 group is at the end of periodic table. At the end of periodic table, in the long form of the periodic table. So why the 0 group elements? Why the 0 group elements are placed at end of each period? See, number 1, total 7 periods. In every period, okay, 0 group elements are last position. In last position. Why the 0 group elements are placed at last group? Okay, na? In period, in last element. Okay, na? So in this lesson we are discussing. Okay, number 2, give the reason for their existence. Monoatom gases at room temperature. Okay. Number 3, state the main reasons for the near total chemical reactivity. Okay, now they are inert gas elements. Okay. And then number 4, describe the isolation of individual gases from the liquid air from atmosphere. So the isolation of individual gases. Okay, now what are the 0 group elements? You know that helium and neon and argon and krypton and xenon and radon. These are the 0 group elements. General electronic configuration is NS2 NP6. NS2 NP6. Helium, neon, argon, krypton, xenon, radon. Okay. Main reason for the total chemical reactivity, describe the isolation of individual gases from the liquid air and state the principles in the separation of noble gases by adsorption on charcoal. Adsorption on charcoal. Explain how rare gases combined with polar molecules. Okay, like HCl and SO2. HCl and SO2. Explain the clathrate compound formation of quinol. Clathrates compound formation of quinol and mention for the use of noble gases. How the noble gases are used. Discuss the bonding in xenon fluorides. Okay. These are the main concept, main objective we have to learn in this chapter. We have to learn, okay, in this chapter. Okay. So start with introduction. See, simple. No need in examination point. Okay. See the introduction. Helium, neon, argon, krypton, xenon, and radon constitute the group of 0 elements. Okay, na? Group 0 elements. They were not known at the time of classification of elements by Mendeleev. These elements came to known only towards the end of 19th century. Okay, na? 19th century. In the early years of their discovery, they were not known to form compounds. Accordingly, they were placed at the separate group. It is designated as 0 group, indicated their chemical inertness and 0 valency. All the 0 group elements, the valency is 0. We have to write He plus 1, Ne plus 1. They are not only He, helium 0, neon 0, argon 0. There is no valency for 0 group elements. Okay, the early years. Okay, according to their place in separate group, it is designated as 0 group, indicates chemical inertness and 0 valency. The elements are placed at the right hand extreme of the periodic table after halogens. Okay, because this position is fitting that bridges the gap between the most electronegative halogens of group 7th A and the most electropositive alkali metals, first A. With the determination of their atomic number and electronic configuration, they were found as NS2-NP6. NS2-NP6, outermost electronic configuration, that is. Helium is an exception and has the configuration is 1s2. Only helium is 1s2. Remaining all are 2s2-2p6, 3s2-3p6, 4s2-4p6, 5s2-5p6, 6s2, like this. Okay, now except helium. It is second, okay, in periodic table, second number 1s2. Outermost electronic configuration is NS2-NP6. The position of element in periodic table is justified the view of their electronic configuration. Okay. A completely filled outermost shell in element renders the chemical inert, and as much as taken up the no more electron into that shell. It can also easily lose electron because removal of electron from completely filled shell requires very high energy. Okay. So these are the inert gas. Why the position of the elements is at the end of the point? Because of highly electropositive is first A group element, highly electronegative is 7th group elements. So these are the 0. Okay, now inertness is, valence is 0. That's why they place it last at the end of every period, at the end of the table, at the end of the table. Okay, see occurrence. Where is the 0 group elements occur? Okay, now where is the 0 group elements are occurred? See, as indicated earlier, the elements, what are the elements? Helium, and neon, and argon, krypton, xenon, and radon. Krypton and radon form the group of 0 group is periodic table. With the exception of radon, all other occurs in the atmosphere air through in a small extent. About 1%. Argon itself account for about 0.9%. Okay. See, occurrence as indicated earlier, elements helium, neon, argon, krypton, xenon, radon form the group of 0 in periodic table. With the exception of radon. Okay, radon, all the others occurs in atmosphere air through just to 1%. In total 100%, just 1%, except radon, just 1% zero group elements are there. Okay, now argon only itself account for 0.9%, only argon. Remaining helium, neon, krypton, xenon is into 1%, but argon is 0.9%. Radon is a radioactive element. It is a radioactive element. Okay. See, this is the occurrence of zero group elements. A discovery. Okay, na? Cavendish, the scientist, Cavendish, a well-known chemist, observed the atmospheric air contained about 1% nitrogen like inert gas. In 1892, Rayleigh experimentally observed for the density of atmospheric nitrogen is higher, 0.5% more. This is attributed to the presence of heavier inert gas along with nitrogen in the air. Okay, so next, this is attributed to the presence of heavier inert gas element with nitrogen in the air. It could succeeded in the isolating gas, but it could not identify the same because its chemical inertness. And Ramsay, a physicist, found his heavy inert gas to be a new chemical element by spectroscopic studies. He named it argon, meaning argon means lazy. Organic means lazy, as it failed to react with metals, caustic alcoholics, and oxygen, and by dry chlorine. About the same time, another inert gas was obtained from the uranium minerals by Hildebrand. Ramsay took the spectrum of new inert gas and found it to be another unknown element. Okay, now the spectrum of this gas was identical with one obtained by the spectral studies of solar corona during the total eclipse in 1868 by Johnson in India and Lockyer in England. See, so this is the invention. Okay, according to Ramsay, the name it is helium, meaning sun. Helium meaning sun. Okay, now so these are all the elements are. Krypton meaning is hidden. See this. Neon meaning is new. Krypton meaning is hidden, and xenon meaning is stranger. Okay, now in these residues of liquid air, radon was the later discovered a product of radioactive decay of elements radium, thorium, and actinium. Okay, now these are the discovery of which groups? Zero group elements. Discovery of zero group elements. Okay. So you know that. Okay, now what is the objectives and introduction, and what is the occurrence? Where they occur? Just 1% in atmospheric air, except radon. Only helium, only argon is 0.9%. Remaining all 1%, and radon is radioactive element. Okay, na? What is argon means? Lazy. Argon means lazy. Helium means sun. Next, neon means new. Krypton means hidden, and xenon means stranger. And radon is one of the radioactive element. It is a decay of radium, thorium, and actinium. Okay, now it is a decay of these three metals, radioactive metals. Okay, see, very important in your exam pattern: isolation of noble gases from atmosphere. Isolation of noble gases. So how to isolate the noble gases from the atmospheric air? Okay, so there are 2-3 methods are there. Okay, very important method is adsorption method. Okay, na? Important method is adsorption method. Method one is fractionation of liquid air. Okay, na? And the only source of noble gases in the atmosphere. The isolation and separation of chemical elements or compounds are generally taking advantage of differences in the chemical properties. Okay, now they show different chemical property. The absorption is or the isolation is easy. Okay, see, but 1 minute. See this one. Next, but since noble gases are chemically inert, their isolation and separation has to be based on their physical properties. The physical property based on mass difference have therefore been employed for the purpose. Okay, na? The atmosphere noble gas are mixed with oxygen, nitrogen, water vapor, and carbon dioxide. Okay, na? No, in the atmosphere, you know that. Okay, na? In the atmosphere, only zero group elements are there. Okay, na? If nitrogen is 79%, 78% nitrogen, and 21%, okay, 21% oxygen, and 0.03% carbon dioxide, and remaining are 1%. Remaining are 1%. Okay, the remaining are 1%. So that's why the atmospheric noble gases are mixed with oxygen, nitrogen, water vapor. In atmospheric also water vapor is there, and last one is carbon dioxide in the atmospheric air. So the water vapor and carbon dioxide are first removed from air by suitable chemical methods. First దాన్ని ఏం చేస్తాం, రిమూవ్ చేసేస్తాం. ఓకేనా, CO2 and water vapor by chemical method. The air is purified, is liquefied and fractionated. Purified and liquefied, liquid laga marచేసి and fractionated. In other method is oxygen and nitrogen also removed by chemical method, and residual gases mixture of noble gases is subjected to selective adsorption. Absorption or adsorption, two are different. Adsorption on charcoal at certain low temperature, followed by desorption. Adsorption and desorption at higher temperature. Absorption is low temperature, desorption at high temperature. Okay na? So these are the methods for the isolation of noble gases of atmosphere. Okay, atmosphere. Okay, now there are two methods. Okay, now method 2, adsorption on charcoal. Method 1 is fractionation, and method 2 is adsorption on charcoal. It is important. So this chart is very, very important. Okay, na? This one is very important chart. Okay, na? Separation of noble gases by adsorption on charcoal. Okay, na? This one is important. So we are discussing in next class. Okay, we are discussing next Saturday. The last only 2 classes are remaining. Next March 5 and 6. Okay, na? In halogens, just you have to read halogen properties, interhalogen preparation, property, structure, and pseudohalogens and polyhalides, and basic nature of iodine. Okay, na? These are the important questions covered from halogens in your exam pattern. Okay, na? In your exam, third sem exam. Okay, right. Thank you.